The key to any definition question is making sure that you have practiced the definitions again and again and again. So the enthalpy of lattice formation, what you are looking for is the enthalpy change when 1 mole of solid ionic lattice is formed from its gaseous ions. And all of the bits that are highlighted here do need to be incorporated in to your definition to get those marks and to get the 2 ticks that you're aiming for. 1.2, and we're looking at the calculation. Now, again, you've got to be able to apply definitions. So knowing the definition is one thing, but then being able to write the equation for the lattice formation of silver iodide is the extra bit on top of that that's going to be required. So I've written that out because that's going to form the basis of my cycle. And my personal preference is to always build the cycle to get to your final answer. So I've done that and I've added x because x is what we are going to calculate. Now from there, I also have the equation for AGI breaking down to AG plus and I minus aqueous, and I've got an enthalpy value for that. So I'm going to build that into my cycle. I can then complete my cycle because I've also got the values for the gaseous ions going to aqueous ions, and I've put those in on the left-hand side. We now have the complete cycle and all of the data that we need to calculate x. Now again, my personal preference is then to identify what the 2 roots are. People do it in different ways. I've got here a blue root and a red root, and I know, according to Hess's law, that they are going to be equal to one another. So I can then put those figures in. X plus 112 is equal to negative 757. And if I then rearrange that to make x the subject, I get to the value negative 869 kilojoules per mole. Now, if you make a mistake in this and you end up with the wrong sign, you still get 1 out of 2. But you are obviously aiming to get the most you can get. On to 1.3 and 1.4 now. So on 1.3, we are talking about the perfect ionic model. That is a big giveaway that we're going to be talking about covalent character beyond the ionic character. Perfect ionic model implies entirely ionic character. So the fact that this value is smaller tells us that silver iodide has got covalent character, and actually you can link that to the size of the I- ion. It's very big, so the cloud can be distorted. So 1 mark for the silver iodide having covalent character, and 1 mark for then linking that to the idea that the forces holding the lattice together are therefore stronger. Then we move on to 1.4, a reagent that can be used to indicate the presence of iodide ions in an aqueous solution and the observation made. Now, I've highlighted here a reagent. So it has to be the silver nitrate. It can't be about the dilute ammonia, the concentrated ammonia, because they come as a second step to this test, the test for halide ions. So because it's a reagent, it must be the silver nitrate that we're looking for. And if it is the silver nitrate, you've then got to remember the colours that you will get for the halide ions, and specifically that with an iodide ion, you would get a yellow precipitate.